Grazie. Okay, good morning. We start from one slide of the previous lecture, which is central to waste management in the sense that it establishes the hierarchy for waste, which is crucial for trying to sort out a waste management system. So basically, the main objective is waste prevention. So we want to avoid producing waste. That's the best option. As I was saying, these options are considered from the best one to the worst one. So waste prevention is going to be the best one, and of course, to prevent waste, there need to be some strategies. There are a number of strategies which are currently under development, and some of them are quite obvious. For example, what could be a strategy to avoid producing waste? Answer, if I go to school, typical answer is recycling. Recycling is not a strategy to avoid producing waste. Recycling is further down. To avoid producing waste, for example, in terms of design, if an industry wants to avoid producing waste, it could use less materials. That's a possibility. Or you could repair. You know that now there are repair cafes where you go and they have some objects for you. Repairing, it's a waste prevention strategy, and also it prepares for reuse. Reuse and recycle are two different possibilities. When you say reuse, that means that you use something again for the same function. If you have a bag, if you reuse it, you give to your friend and he reuses it like a bag again. So for the same use. Or you can try to use for a slightly different use, but not going to another system. For example, yeah, you could use a box which was packaging. You can use it as a piece of furniture. Then it's no longer reuse. It comes down. It's between reuse and recycling. Well, what I want to say is that these options are not really disconnected from each other. They have some kind of superposition with each other, because in some cases, waste prevention, it's also preparing for reuse. I could, for example, repair something and you try to use it again. So there is a lot of discussion about this directive, which is 98/2008. When we say recycle, what does it mean, recycle? Is that we use something in another form to produce another object, which may be the same object. We were discussing last time about aluminum can, say a Coca-Cola can. You can use it again as another can. The problem with recycling, the difference between reuse and recycling is that reuse does not necessarily involve the consumption of energy. Recycle always requires the consumption of energy. And as specialists into waste management, we cannot use recycle, the term recycling in the popular way. Recycle means that you are consuming energy. Which kind of energy? So we were saying, basically, we have three main kinds of energy about recycling. So we were discussing last time, how do you recycle plastic? What do you do? We take that bottle and you grind it. So you have kind of mechanical energy. You grind it, then you melt it, which means that you have a thermal energy. In the worst cases, when it's badly damaged and so on, you may need possibly to come back to the initial monomer in case of polymers, in case of plastic. And so you may use a chemical energy. This is general because you may transform it chemically and so produce other molecules and so on. Which may happen also, it's not only typical of plastics. For example, in steel, you may have rusted steel, and in order to recycle it, you may need some chemical treatment. For example, treatment with acids like chlorhydric acid, and then to avoid having a rusty steel and to have a sort of new steel and then reprocess it, and then starting with mechanical and thermal energy and so on. Okay, so these are the three main categories of energy that you use for recycling. Recycling is an option that leads to a material which has less value than the initial material and it is in less quantity, so it's often called downcycling. It leads to downcycling. So, which means that you have less material of less value. In the case of plastics, well, you grind it, then you melt it, and in the end, you have a sort of jelly material. In the case of that plastic like PET, you have a sort of jelly material. We were discussing last time, how do you produce the bottle? You produce the bottle by injection molding. That's a typical fabrication technique, injection molding, which means that you inject the material into a mold and then you sort of print it. It takes the shape of the mold. The question is that the recycled plastics may not have the same properties than the initial one, the new one, which means that it doesn't flow the same way, at the same speed, with the same accuracy, and you don't get the thickness which is constant that you desire, the same shape of the mold. What do I mean by that? I mean that plastics, when you inject into the mold, is not a liquid. It's a sort of fluid, which is a viscous fluid, which means that it's more similar to a ketchup or a mayonnaise or blood or whatever. And once I recycle it, it might be contaminated and it might flow slower, which is a problem because I need to obtain the precise shape of the bottle if I am producing bottles, which means again that I have to add some new material. Possibly I cannot recycle 100% of the bottle. I may use, for example, 50% of the recycled plus 50% of the new. Another problem with water bottles is that there is a characteristic why I use that plastic instead of other plastic. You will never see mineral water bottles made of ABS. ABS is a very popular plastic to make furniture and lots of plastic pieces. There is a characteristic which almost all plastic bottles have, water plastic bottles have, which is very important, which is I like to see water inside, so it needs to be transparent. The problem with transparency is that it's a subtractive characteristic. Subtractive characteristic means that I cannot obtain it, I can just lose it. So the recycled plastic will not be transparent, which people selling water bottles don't like. In the end, you will never see ABS or silicone water bottles because they are not transparent. You may see some other kind of bottles, the bottles which I fill, water bottles which I fill myself, that would be fine to make them into ABS or into silicone or whatever. Another thing I would like to say, if there is something you don't understand or it's not clear to, please interrupt and I will be happy to discuss. So, below a certain quality of the material is no longer the case to recycle it, because it may come down in properties, which means it may come down in price as well, which is a problem because after differentiate waste collection, there is the market, and it needs to have a market. There is to be someone which has to earn some money from that. In some cases, I was discussing last time about styrofoam, polystyrene, styrofoam that, like these panels could be recycled. The problem is the same as the reason of their success. The success of polystyrene panels is that they are, why everyone uses polystyrene? It's cheap and light. That's the two main reasons. Which is also the reason why it's difficult to recycle them, because to earn some money from recycling them, because they are downgraded into properties, and in the end, they are worth few cents or even less per panel. In the end, it's very difficult to produce something else by depolymerizing them, by using a chemical deconstruction to come back to styrene. And from styrene, you can make chemicals and so on, and to earn some money. So it might be the case that you cannot recycle materials anymore. So the last thing I am saying now about recycling is that recycling involves the fact that you have a number of cycles, a number of lives, if you want. So you may have a Coca-Cola can, and then again a Coca-Cola can, and this may happen 4 or 5 times. Recycling cycles, so lives, because it doesn't degrade much. Aluminium doesn't degrade as much as plastic. but after 4 or 5 times, you come to a point that the mechanical properties are much lower, and then you have to downgrade your application. You don't have anymore the capacity to form the aluminium into a can, and then you downgrade it. For example, an aluminium downgraded application is foil, Spagnolo, foil. It's downgraded because you don't need to form in a precise shape. You make some foil, yeah, you still need some tensile, but the thickness may be even lower. You may consider to add some other fillers in order to make it formed into a foil. And in the end, you see that it's a lower mechanical application because it's much easier to damage than the can. So the mechanical strength is much lower. So in the end, after 1 or 2 lives as a foil, it has to go to other recovery, and possibly you may consider melting and reforming aluminium with the new one. So coming back to recycling, recycling involves the fact that we have a number of lives which may be a few for aluminium, which may be even more for copper or iron or steel, and then you may have almost infinite number of lives for copper, because they have, and for steel and for other metals, titanium for example, you may have a number of long lives. The problem with metals is not that they are downgraded, they lose quality with recycling. The big problem is that, what is the problem in recycling steel in reality? Well, we may consider, instead of reforming steel, instead of reusing steel, and making it another object, we can consider to have a thermal recycling of steel, a mechanical and thermal recycling of steel. But then what is the problem there?
Cost of energy.
Cost of energy, because with plastic we are talking about 200, in worst cases 300 degrees. Steel we are talking about 1,400 degrees. You may make this parallel that we have the same problem with cement. Cement could be produced newly produced, but you have to extract from the quarries. Then you have to make it workable, you have to heat up at 1,400, between 1,200 and 1,400 degrees. It's a lot of energy. So in the end, the best option is to reuse it. I was saying last time, the copper wire, as a copper wire. In electrical wires, it's almost infinite. Usually, you can use it for many years, again and again, which is not expensive and so on. Then you come down to other recovery. Other recovery means that you can produce energy. You can produce energy by incinerating them. There are different techniques, but we will discuss them later on. And again, incinerating them, you need to produce energy. You can produce energy, which means also that you are left with some waste again. When you incinerate, you are left with some waste, which are, as we were discussing last time, ashes. Plus, in the case of plastics, you cannot incinerate plastics because you may have some toxic gases and vapors, like dioxins or furans, which are toxic, but there are a number is more. But we'll discuss about environmental impact later on. Basically, it's not possible to incinerate plastics. It's not worthy to incinerate just to produce energy metals. What is left is that you could perhaps consider to incinerate end-of-life paper. Paper has got 4 or 5 lives typically. You start from white paper, then you come to no longer white paper, recycled papers, then you come to cardboard when you obtain the mechanical resistance through the thickness. And typically the last life is packaging containers, like egg containers or even thicker. Now in packaging you find some packaging items which are even a few millimeters, more than a few millimeters thick. For example, they are put in cases for electrical equipments like computers and so on. You may find this kind of packaging items which are very thick. So paper is made of, what is the main substance which makes cellulose? Okay, cellulose, which in a sense it could be incinerated. You have cellulose, and which is typically taken out of which plant is usually used to make paper, because we have no longer primary forests. When I say primary forests, I mean the forests which were present already before the man came into the world. So very ancient forests and so on. Primary forests are no longer present around the world. And so we have just secondary forests which were planted at some time, some point during history. Which, you know, which kind of plant are usually cellulose extracted, cellulose for paper making. It's usually poplar. Which is quite strong, has a quite strong resistance, and while containing a lot of cellulose. Coming back into chemistry, what is cellulose made of? It's a derivative of what? Of sugar. It's a polysaccharide. Polysaccharide, so it's a derivative of sugar, of glucose in general. Of saccharose, then of glucose, of course. Coming back to the initial molecule. So it's a derivative of sugar. Then there is some, so it's sugar would be fine. You can of course burn sugar in principle, and you don't have any particular problem. The problem for which you are not able to, well, people are not very happy if you burn paper. It can be burned paper. It can be burnt paper. It can be burnt when you start from your sheet of paper, which is white and has long fibers. The problem with cellulose is that going down and down into mechanical recycle, so you chop them and you reduce the dimension of the fiber. When you reduce the dimension of the fiber, the tensile strength when I pull them, it becomes lower and lower. So I need to compensate to make them thicker into cardboard. If cardboard would have the same thickness of the initial sheet of paper, it would have no resistance. But I make them thicker and it works. Then packaging items like the ones which are recently used for eggs and so on are much thicker, but the fibers are shorter and shorter. In the end, when the fibers are very short, I call that kind of material a cellulose pulp. The cellulose pulp, you know, when you may have heard the movie Pulp Fiction. Pulp was considered a paper of low quality. So the novels, the books which were published in a pulp were called in cellulose pulp, were meant that they were published in a paper which was even lower than the common recycled paper, with fibers very short. Plus, if the fibers are very short, they are never oriented. They are put in a random way. You haven't looked at the microscope for your egg container, but if you look at the microscope, you find very short fibers which are put in a random way. And so you get some resistance. Why it's not, well, you can do that. You can incinerate the plastic, the pulp. You can incinerate the pulp which came out from the pulper, because basically the machine is called the pulper. Once you have the, after you have the cardboard, when you recycle the cardboard, the problem in recycling the cardboard, you can recycle the cardboard, but you have to get rid of what? Cardboard. Cardboard is put together through layers of cardboard which are put together through, which is a big problem. Glue. You may have different glues. Often you have vinyl glue, a vinyl, which is the most common one for paper. And the problem with glue is a type of polymer. It's a type of polymer, but it is a type of polymer which doesn't really melt. We were discussing last time that plastics may be thermoplastic, like the one of the bottle, and you are able to melt and to form into a shape, or might burn with temperature, like wood. Wood burns with temperature. Wood doesn't burn. It burns with temperature, and it's called thermoset. Thermosetting, like glue, are good because I can process them at room temperature. So I put glue and I put the two layers of cardboard together, and they stay together at room temperature without heating and so on, which is very convenient in a lot of applications. But thermoset are not recyclable because they tend to burn at high temperature. What is the problem in incinerating pulp, cellulose pulp? Is that pulp is white. At the beginning it was white, then it went down a number of transformations, but pulp it's white because chemicals were applied. Chemicals based on which element do you think when they were applied? Which element do you think? When you want to do bleach, for example, bleach. Candeggina, based on which element? Well, vinegar wouldn't be a big problem. Wouldn't be a big problem in the end. The element of bleaching is chlorine, and it may give sodium hypochlorite and so on, and it gives some toxic vapor as well, and we can discuss about that later on. So in the end, I cannot, well, it's not worth incinerating the metals because it's better to reuse them, and so there is no reason. For metals go down a number of lives, so there is no reason to come down to incineration. I cannot incinerate plastic because of the dioxins and fluorines and so on. Other options are possible. I wouldn't incinerate. For example, there is no reason to incinerate glass because glass as well. Well, what is the raw material for glass? Silica. Yeah. Okay. So silica. I can come back to silica. Silica is an inert, and I can fabricate glass again without not many problems. There is silica, and from which element is color given into glass? Silica plus. For example, I have green glass, yellow glass. Yeah, they are sort of pigment which are made of oxides, metal oxides, like iron oxide, and also other types of oxide, vanadium oxide, and so on. And so in general, there are metals involved, metal oxides. We can discuss later on glass as well. Okay, so no plastic, possibly paper, but it's not very good. No metals, no glass. What is left that you can incinerate? The so-called biomass. There is a precise definition of biomass, which is a mass of biological origin, which is mainly based on wood. Well, the main component of biomass is wood, because wood again is formed by polysaccharides, but by another polysaccharide which is more thermosetting. How do you distinguish between wood and herbs, plants? A plant can be woody or not woody. And it depends on the fact that a woody plant has got a more thermoset polysaccharide, which is called lignin. As a rough explanation, when you have more than 50% of lignin and less than 50% of cellulose and other components, you have wood. Otherwise, you have vegetable plants. You have plants. Anyway, most of biomass is wood. So you can burn wood and other plants. And this has a lot of problems again. This has a lot of problems because you are left with ashes, and ashes need to have not to have a toxic component, because the problem is, why should you have ashes with toxic component? Because you burn wood wood was planted somewhere, and it absorbed from the soil, for example, heavy metals like chromium, like vanadium, cadmium, and so on. Then they don't degrade into wood. The tree is able to live even with toxic metal inside because they are inert into the wood. But when you burn them, of course, you burn wood at 300, 400 degrees. Even if it is more, the heavy metals are not affected, and you find them into ashes. And then they are special waste, and you have to separate from the rest of ashes which are derived from wood, which is not easy. Can be done because based on density, because density is very different. The density of wood is around 1. The density of these heavy metals may be much lower, maybe 8, 9, well, and so you can separate in terms of density, but it is a problem, of course. You need to filter all that. Then there is disposal, and in theory, disposal needs to be disposal, which means land filling. So you discharge in a part of land where you start when you can fill a hole or a quarry which is no longer used, and so on. We were saying last time that there are a number of materials which still are disposed into landfilling, which represents a problem. We were discussing last time about CDW, which means construction and demolition waste. And this represents still a problem because they need to be disposed in special landfilling sites, and they may have valuable materials, iron, but they may have toxic materials like asbestos, and in general terms, it's a waste. It may be a waste of money and a waste of land, of space. In fact, as I was saying last time, in the Netherlands, they started even in the 90s to start to concentrating on recycling or reusing, in the best cases, these materials, because they had no land, basically, no land to put them, kind of flat and overpopulated land. Okay, let's go further for another few minutes. So I wanted to say just a few more things. We want to avoid downcycling, and downcycling means recycling that loses value. You lose value because you have less material and because it's worth less. The opposite of that is upcycling. Now, they are talking a lot about upcycling, which means that it's a recycling done with sustainability criteria. When you talk about sustainability means 3 things. We concentrate on the first one, but we need to know that also the other 2 are important. So the environmental sustainability means that what we produce need not to be harmful for the environment. Then we will try to differentiate about the possible harms for the environment, because there are different ways in which the environment can be harmed. For example, acid rains is a way. The ozone hole is another way. For example, the greenhouse effect, so excessive production of CO2. Now, also because there is also this discussion about the Greta Thunberg activities, they concentrate a lot about greenhouse effect, which means that we have too much carbon dioxide. We need to have some carbon dioxide to live, but if it is too much, it may create a global warming and so on. But there are a number of factors for environmental problems. Then, of course, you need to have an economically viable system, which means that once you collect everything, as I was saying, someone has to make money out of that. And it needs, for example, to compensate for the costs of, say, transportation. As I was saying last time, the best way to recycle is to recycle at 0 kilometers. What the European Union has put as central is the polluter pays principle, the 3P. Polluter pays principle means one very simple thing, is that if you are, say, an industry that work, say, with cow milk, say, then you produce, of course, some environmental damage, then you have to pay for that, which means you need to dispose of your refuse on site, if possible, it's the best option, or otherwise you have to provide some techniques in order to reduce the environmental impact. So the idea in the long term, the idea of the polluter pays principle in the long term is that you would need to reduce the transportation costs and also to avoid polluting other places. Also because it may be also the case that the industry producing, even food industry, does know which kind of additive they have put in their food and so on. As you go further away and then the industry gives the food waste to, say, a city council, which has to dispose for the food waste and whatever, don't longer know what is in that refuse. So it's best to, also for construction and demolition waste, it's best to try to dispose of it on site. Not just because for transportation costs, but because you know what's inside. For example, you know that you are using a lot of bricks, kind of bricks, and where you get the bricks from, where do you produce the bricks. So you are the best person to try to reuse those bricks. Then there is the social environment, the social sustainability, which means that you need to produce materials and to try to have also design of materials in order to not to create social problems. It's important to know that, because in some cases what happens about waste, it's the so-called dumping. What does it mean, dumping? Dumping means that it's a term which comes from the economical field. Dumping means that I sell a lot of products here, then the prices is going down, then I sell to another country. And where the market is not yet saturated. Dumping means, in environmental terms, means that I may sell all this refuse, and you may imagine it's still happening. I may sell all this refuse to another place where, for example, the regulations are more relaxed. For example, in Europe, I have to comply to the European regulation regulation, I have the refuse from waste from electronic and electric equipment. I say I have the rare earth. I cannot find here people disassembling a computer by hand and also being exposed to some toxic environments. I can give to some other places. And this is no longer possible. So that's why there is this social aspect which is important as well as the environmental and the economical. So solve my environmental problems by selling to somewhere else, which is usually still done, because you may consider that in this region we have a lot of waste from Rome, which in Rome they have too much waste, and they sell to some other places in order even to be landfilled. So that's why we need to have a global system, because you can close your landfilling site. You need to ensure that also your neighbor is able to close his landfilling site, because otherwise it will never work. So we need, in the end, the objective is to comply to the same regulations. A very last, this I would conclude the first slide. Then we start, we do a short break, then we start with a new one. The new slides. So this is a kind of, this is a design which has done a kind of upcycling, these were, for example, pencil scraps. This gives you an idea of what upcycling means. The more famous case of upcycling about plastic was pile. You make from PET, you make pile, which is mechanically is worse than. Mechanically and in general terms, structurally is less work than. These pencil scraps are mechanically worse than the pencil, but they can be sold at a higher price because I find a way to confer into them value, because expressive way, because they in this case, but this is only a trick, but maybe anything. In the case of pile, it is a textile. Instead of make a bottle, which they were coming from the bottle, which was worth 3 cents, then I can make pile, where the material is less worthy because in the end the mechanical resistance is very low. But I don't care about the mechanical resistance, and I give value to design, to marketing, and so on. But it works in the sense that I will not throw away that collier very soon, which has a relation to waste management in the sense that waste is what is not longer used. And about the directive, the 98/2008, what it means by saying that waste is secondary raw materials, it means that this was waste, but you decide you shape it into a collier, you sell it, then it's no longer waste, it's a secondary raw material. At that point, I don't care what you do with it, provided you do an upcycling application. Then you can have materiamorphosis, so you can integrate the material into an adapted context, so you change context because you pass from the paperwork, basically from the pencil, from the school context, you pass to another context, and you give value, you give more value. That's why these upcycling systems, they tend to make bijouterie or textiles and so on, because these are fields which have a very high added value. High added value means that I produce less waste. This might be a provocative approach, but to a point it works, and it suggests possibility for reusing it. Then the main problem, you may have seen, for example, the Adidas shoes, which were made with bubble gums, basically with And it's a good point. It's a good point. The main problem is in this kind of operation. Adidas may do that because they have lots of money and also, for say, one of the most polluting material is cigarette filters. Cigarette filters are cellulose acetate, but they are filled with all sorts of toxic elements and so on. What's the main problem? For what we were discussing before, what's we have to start? The first point into waste management is differentiated waste collection. So the main problem, also for pencil scraps, which are not as dangerous as cigarette filters, but the main problem with cigarette filters is to collect a significant number of them in order to make something. Because if I have 2 or 3 cigarette filters, well, I am lost. And that's why Adidas has done the shoes with bubble gums. They have collected them. Well, it's a bit, well, it's not very nice to think of, but also cigarette filters is not very nice to think of, but you can wash them and to put them into a material. But you always start from waste collection. That's the starting point. That's not the final point, because in the end you have to make money out of it. Okay, we stop for, say, well, 10 minutes, and then we have another 20 minutes or so discussion about other matter from the second part. Okay, we have about half an hour left, and I wanted to start with some discussion about some terms that you found out in the book you may have read. There is this book in the material I've given to you, which is a descriptive book. It's not basically, it's not just a scientific one, which illustrates the visions about waste management. And you find a number of terms. There are more, but I have put some of these, which are very important in terms of the psychological aspects of approaching waste management, which reflect on the fact that you produce more waste. So I wanted to discuss with you about these terms because they are continuously mentioned, and they are mentioned in that book at different points, in some cases a number of times, and they have an influence on the production of waste. So, for example, starting from the first one, there is a lot of concern about fast fashion. What does it mean about fast fashion? I've finished the first part by talking about PET and PILE. A big concern, well, because let's step back. the idea is that we want to produce less waste. The ideal would be that we don't produce any waste at all. But of course, this is an ideal. So fast fashion, what do you mean by fast fashion? What do they mean in this book? So fashion means the production and the use of textiles and clothing and so on. Fast fashion is a problem for waste management. Why? Why so?
Because it changes
Because
very often.
it changes very often, and you throw away something which is no longer used by you, but could be used. Could be used, and you can, for example, collect and give to someone else. So fast fashion is connected with something. It's the opposite of something which is very important about. Well, the idea, as I was saying, the idea is to produce less waste as possible. And what is suggested as well is need to have an intensity of use. That's a good. Well, fast fashion is opposite to intensity of use, which is a good characteristic to produce less waste. Intensity of use, for example, applies also to cars. Scrap cars, for example, is one of the special waste which needs to be disassembled and so on, which represent a big problem. The places where the cars are disposed of are usually places of big environmental concern because of batteries, because of oil, because of the presence of resins in cars. Well, we can consider later on also the disassembly of the car, which is a problem. What is the relation between intensity of use and cars? Because now a big concern into environmental discussion is that cars have, with people becoming older, average age of the people becoming older in Europe, higher in Europe. So the intensity of use is reducing, which is a problem for waste management and so on. What do we do? Well, let's try to find a definition for intensity of use.
The fact that after 5 years or 10 years, they change vehicle.
Yes, they change. Yes, that's, well, possibly, but intensity of use means that you may have a car which is parked 80 or 90% of the time, which means that as you have a low intensity of use, very low intensity of use, and there is another person, perhaps also close to you, which is still using his or her car for 10% of the possible time. There is a lot of discussion, for example, about the possibility of renting the car when needed. You hire a car, and then you use it. And you don't own a car. Because we need to have less items, more intensely used. That's a good environmental procedure. And of course, with fast fashion, it comes the addition to novelty. Addition to novelty means that, I know that something new is coming out and I need to have it, even if I don't need it, really. This is another problem for the overproduction. You get to the overproduction.
Then there is a big point, which is the planned obsolescence. The planned obsolescence, well, there is a lot of discussion because someone says that planned obsolescence exists. It exists in some fields, it doesn't exist in others, it's more difficult in others. It's typical of the computer or phone or cell phones field. So you need to buy something new because the old one is obsolescent. For example, there might be a number of tricks to make something obsolescent. For example, your software doesn't work anymore. You need to upgrade, and then your cell phone is no longer able to cope with the fact to upgrade it. So, conclusion, you need to buy a new one in order for the new software to work, the new version of the software to work. Or there is a lot of discussion in Europe about the adapters. The adapters which adapt a plug to another into your cell phone, into your PC and so on. Because with a number of adapters generate a lot of waste, which is a waste from electrical and electronic equipment. We generate a lot of waste. That's a big problem because it opposes to one trend which is important, which is the so-called standardization. Standardization is very important to the industry. Standardization means that you can make the same operation, say putting your plug into the point, into the electrical point, same way with the same system in different countries. Mechanical standardization, we are almost there because basically in all countries in the world, the same screws, the same rivets, and therefore the same screwdrivers and so on. Electrical standardization, we are halfway because there are some countries which don't comply to the same standards. In European Union, more or less, we have the same standards for plugs and so on. We are still working on electronic standardization because we have a lot of adapters which are continuously introduced on the market. The most typical example, for example, you have the adapters for the Apple iPhones and for the iPhones and the other iPhones which have got the other cell phones which have got other type of adapter. For example, another example of the adapter, you have we started with the BGA, and then we have the HDMI, and then we have the USB, and these are all different. Then they stopped a bit on the USB because, of course, the consequence of that is that you produce a lot of this kind of waste in terms of cables and so on. Then you have the cross-sectional waste prevention, which means that you need, well, cross-sectional means that if you want to prevent waste, well, waste prevention, that means that you want to produce less waste. Cross-sectional means that you have to consider the waste prevention strategies in the whole productive system, which sometimes is not very easy to make. For example, if you produce food and then you come down to packaging and so on, you would need to consider waste prevention strategies at every step in industry. from the person that physically produce food. Say, if we produce a cake, it's supposed, and then we sell as an industrial cake, say an industrial plum cake, consider waste prevention into people producing flour, producing milk, producing sugar, then making the cake, so making the mold for the cake, packaging the cake, transporting the cake. There are a number of steps. You may consider that plum cake, it's a small object, and you may consider that it's very simple. In reality, you can see that you have a number of steps, because flour means that it's created from wheat, which means agriculture. Then you have milk, and which means cow breeding and so on. So it's an ideal, it's very difficult to apply all that, because there are strange situations, especially in waste production, in food production, sorry, and where you, for example, you may have a yogurt whose brand is Italian, but milk from which the yogurt is produced, it's milk of different origin. So in the end, it's difficult to trace down, you know, ability. So to trace down all the places in which, and all the industries in which all the materials that come down to your food were produced. That's why they are trying to get to this. The problem is that in some cases the European Union had made things worse, and in fact there are some regulation. For example, in about 10 years ago, I will find the right regulation, the right directive. I will tell you later on in one of the next lectures. For example, olive oil from 2007, 2008, you are allowed to mix oils from different origin into your oil, which reduces the cost, of course, but might be a problem, because if you want to trace down that everyone using oil, producing oil, has tried to minimize the waste, has tried to apply and has tried to apply the waste prevention, you may find out that for a single bottle of oil, you have to contact 10 different industries from different countries. This wasn't allowed before 10 years ago. The oil from the bottle should have come from the same producers. Now you can find that can be a mixture of different oils. And this is an example, but which means that it's not that easy as it appears. Waste management sees waste as a mixture of valuable material. So you need to avoid the production of further waste. You need to see waste as a mixture of valuable material and separate this and sell this. And be sure that there is a market for it, because in some cases there is no market for that material. In the sense that the material has not worked even the transportation. It doesn't cover even the transportation cost to the site that has got to recycle. And that's a big problem. Well, also important, post-consumer waste. That the waste should just be post-consumer one. In the sense that in some cases there is a waste which is before consuming. What do I mean? If you make, say, plastic cups, plastic coffee cups, if you have a 10% which are defective, that means that this is not a post-consumer waste. It's a waste even before consumption. Ideally, we should eliminate pre-consumer waste, in the sense that we should reduce more and more the defects in to the industry. So there is a correlation between reducing the defects of fabrication and producing less waste. Well, this is very important in this region, resistance to change. Resistance to change means that we have already a strategy which doesn't involve applying waste prevention. Say, we always brought our waste into that landfilling site. Once the landfilling site is closed, that was happened in Rome in 2015, they closed a big landfilling site. The consequence was that people which were bringing with trucks their waste to that landfilling site didn't have a second option, didn't know what to do. So that's why comes resistance to change. So you have to supply a strategy before you ask for a change. Let's say we don't throw oil anymore down the drain and we collect vegetable oil, but we need to be clear about where we do it, what we do with that vegetable oil once we have collected it, and so on. A big problem is about the surplus food and leftovers of food which is left, which can be recovered and so on in having other options and trying to repurpose it in other food and so on. So food waste is still, we have still huge numbers of it, and in different sectors. To conclude, I just wanted to show you that we haven't applied yet completely the 2008-98, which establishes waste strategy. But we have a new directive in 2018, the 859-862, which is aimed to integrate the 2008-98. 2008-98 says that we have secondary raw materials. The problem is that they realized that, well, you can say that waste is a secondary raw material, but you need to have a market for it, which possibly in 2008 appeared obvious for the most part of the material, which was not the case. In reality, there are some types of waste which have no market, which were neglected in 2008-98. For example, one example was biomass. One thing which you should be considered is that you can burn biomass, which is a possibility. But there is some kind of biomass, there is a definition of biomass which I'll give you later on, but it's understandable. Then, of course, there is a political definition of biomass which is more precise, because then you come to a point where you don't know exactly what biomass is, because in some cases, as I was saying last time, the biological activity is too slow. Think of muscle shells. Muscle shells, well, there is a biological activity. Eventually, some biological organism will interact with the muscle shell, but it's so slow that it's of no interest if you want to burn or if you want to recycle even in some way. The problem, for example, is that they realize that with biomass, in some cases, there is no market. For example, if you have lots of resin into your plant, or with leaves, think of leaves, you can burn leaves, but those leaves give a calorific power which is very low. So in the end, it's possibly not worthy to lots of smoke, lots of smoke. So in some cases, you may have no market. So end of waste strategies were defined with the idea that every and each material need to have one end of waste material, end of waste strategy. Now they are increasingly putting it like that. E capital, then O, then W, and E and W are capital. And of waste. So for every material, we need to have an end of waste strategy. You may understand that the first end of waste strategies were done for the easy materials. The first end of waste strategy we came out for was for copper. Copper, it's easy. Then they are doing something for steel. They are starting to do something, and for rare earth, because rare earth it's necessary not to lose any of them because they are really rare and they are extracted in some definite countries and so on. But for other materials, it's very complicated. The idea to put the end of strategies, it's also to call on the responsibilities for industry, for example, for plastic industries, to create less type of materials and to try to match the different types of material between them. So to standardize the type of recycling we can apply in terms of mechanical, chemical, because this is a general framework. I cannot talk about everything, but if you talk about mechanical, for example, everyone grinds in a different way, at different dimensions of powder and so on. Melting temperature, yes, it's about the same, but plastic is not a crystal. It's got a range of temperature, of melting temperature, and it depends on the very last thing I want to say. To make it flow, for example, plastic, you make it flow into the mold. It often because it's a good example. If you want to make slower, because of course two things may happen. Is making a plastic bottle is like making a cake, and you may find out a few problems. For example, you don't fill the mold, like making a cake, or you don't fill the mold, or you heat too much, which is a problem, and it's also money. And it's not easy to calculate with plastic because it's not a crystal again. So it's got a temperature range. If you want it to flow more slowly, what would you add? Which kind of material would you add? Something which doesn't flow at all. In fact, you add it, a kind of ceramic, say talc, say, or calcium carbonate or silica. The problem is that from industry to industry, it changes. It changes the amount, it changes the type of geometry, it changes the mold. In the end, it changes the end of waste strategy. It's difficult to make an agreement on plastic because there are a large number of plastic types and so on. Then there are also cases in which it is really difficult. For example, thermoplastic, thermosetting resins, it's really very difficult. And also, when you have a very valuable object, the end of life is very difficult. Even more than cars, the end of life, which is most difficult, is the one for ships and for yachts. Because usually, what do they do if they have a yacht at end of life? What do you think they do? They There are basically two options so far. That's why it's a big problem. They make it sink down the sea, and then it's left down there, or they transfer it to a poor country where they recover the material, which are not valuable for us, not valuable for the yacht property, because if the yacht is worth 2 or 3 million euros or so, even if they have a golden sink, it's not worth it to recover the golden sink. But if you transfer to a poor country, to a third world country also, they appreciate that, and they are able to disassemble. Of course, disassemble not in an industrial way, but in a casual way. So it doesn't work very, very much, but it will take time because before we have a end of waste strategy and a disassembly for the materials which are involved in the construction of aeroplanes, or of ships and yachts. In aeroplanes we have small aeroplanes. We have a big problem with glass, with fiberglass, because you could dissolve the resin, which is not environmentally friendly. The epoxy resin, you could dissolve it in acid, like in nitric acid, and recover. But you don't make much money to recover in the glass, because it remains quite sticky with resin and so on. It's not you cannot make a window with that, even a window or something like that, or a mirror. In fact, in the mirror, what do they do? The end of life of a mirror, you don't put a mirror in the differentiated collection, waste collection, because in the end, the part which is worthy in the mirror is the silver back of the mirror. So they destroy, or they throw away the glass, and they tend to recover the metal. Okay, so you see, it's not as easy as you may think, but end of waste, it's the end of waste for any material. It's what it's required in the next few years. It's the challenge for the next few years. Okay, we will have no lecture on Thursday, because I'm busy in Ascoli, and we will have a lecture on Monday. I think you are almost all of you there, so I will send an email anyway. So we will see here on in a week time, so next Monday. Of course, if you have any doubt, and we have done just 2 lectures, but if you have any thought about the kind of part of the waste management you are more interested in, which means materials, which means industry and so on, you may send me an email or discuss. Anyway, I'm here also in the afternoon. Okay. Arrivederci.
Ciao. Io vengo a
Sì, benissimo.
recuperare.